Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2022 Fluid Mechanics questions with solution. GATE 2022 question paper and answer key link is available in my description box. You can download it. Question number 51. Two reservoirs located at the same altitude are connected by a straight horizontal pipe of length 120 meter. L is equal to 120 meter and inner diameter 0.5 meter. So ID is equal to 0.5 meter as shown in the figure. So the figure is given, refer this figure. So here L is equal to 120 meter, inside dia 0.5 meter. A pump transfers the liquid of density 800 kg per metric cube. So rho is equal to 800 kg per metric cube at a flow rate of 1 metric cube per second. Flow rate is denoted as capital Q. From reservoir 1 to reservoir 2. The liquid level in the reservoir 1 and reservoir 2 are 2 meter and 10 meter respectively. So Z1 is equal to 2 meter, Z2 is equal to 10 meter. Okay. Assume that the reservoir cross section area are large enough to neglect the liquid velocity at the top of the reservoirs. So velocity neglected. So V1 is equal to V2 is equal to 0. Okay. So this is neglected. All minor losses can be ignored. So this is very important line. All minor losses can be ignored mean consider the major losses. So the acceleration due to gravity is 9.8 meter per second square. So G is equal to 9.8 meter per second square. If the friction factor for the pipe flow is 0.01. So friction factor is denoted as small f. So the required power of the pump is, so in kilowatt. After calculating the power of the pump value, we have to round up the result to 1 decimal place. Objective of this problem to determine the power of the pump in kilowatt. Okay. Data. So length is equal to 120 meter, inner dia is equal to 0.5 meter. This is a pipe dia. So density of the liquid 800 kg per metric cube, volumetric flow rate 1 metric cube per second, reservoir 1 height 2 meter, reservoir 2 height 10 meter, velocity neglected, we should take V1 is equal to V2 is equal to 0. Minor losses neglected, only consider major losses. So here major losses are considered. So only minor losses neglected. Okay, this is considered one, major losses. So here G is equal to 9.82 meter per second square. F is equal to 0.01, this is friction factor. Objective of this problem to determine the power of the pump in kilowatt. Okay. Solution part. So here this is pump work in Bernoulli equation. Here P1 by rho plus V1 squared by 2 plus G Z1 plus neta into Wp is equal to P2 by rho plus V2 squared by 2 plus G into Z2 plus HF into G. So both reservoir open to the atmosphere. So P1 is equal to P2. So this is cancel is right, P1 and P2. So then velocities are neglected. So V1, V2s are cancelled. So here what is the neta into Wp? So neta into Wp term is a mechanical energy delivered to the fluid. That is neta Wp. So here neta is a pump efficiency. So assume neta is equal to 1. This is 100% efficiency. Neta is equal to, we should take 1. What is Wp? WP is nothing but pump work per unit mass of fluid. Pump work mean that is a joule, unit mass of fluid mean kg. So the unit of WP joule per kg. So WP is nothing but pump work per unit mass of fluid. So work is a joule, mass is a kg. So joule per kg is a WP. Are you clear? Okay. So here rest of the term. In LHS side, G into Z1. G is 9.8. Z1 is Z2 plus WP. WP is a joule per kg. So this is we are going to calculate. So this WP is nothing but pump work per unit mass of fluid. Okay. So here RHS side G into Z2 9.8 into Z2 value 10 meter plus HF into G. So here HF is a major losses. Why? Because minor losses are neglected. The problem itself they have mentioned minor losses can be ignored. Only consider the major losses. Okay. So here we are going to calculate the HF value. This is a loss of head due to friction. So here G value is a 9.8. Okay. So here substitute all these values unknown here WP and HF. So but we want WP, but we need HF value. So HF is a major losses. Major losses formula from Darcy-Weisbach equation. So this equation is commonly used for finding the loss of head due to friction in pipes. So this is Darcy-Weisbach equation. HF is equal to 4F LV squared by D into 2G. So here F is a friction factor, L is a length of the length between two reservoirs is right. So here V is a pipe velocity. So pipe diameter is a D. G is acceleration due to gravity. So here HF is equal to 4 into F values are known is right. L also given. So diameter is given. G is a constant. We want V value. So this velocity calculated from volumetric flow rate formula. Volumetric flow rate is equal to area into velocity. So here what is the area? Pump area pi d squared by 4 into V is right. Pipe diameter is given is right. Inside dia is a 0.5 square divided by 4 into velocity V. So from these velocity is equal to 5.09 meter per second. The velocity units are meter per second. So here take the velocity value directly. Okay. So HF is equal to 4 into friction factor value is 0.01. Length is given 120. Velocity is calculated value from volumetric flow rate formula 5.09. Here V squared is that, that's why squared. Whole divided by inner dia is a 0.5 meter. 2 is that. G is a 9.81. So after substituting this value, determine the loss of head due to friction, that is HF value. HF is equal to 12.675 meter. So the habit is come meter value here. So the F is no unit is right. Length is a meter. So numerator part meter is there. Velocity is a meter per second. But here velocity squared mean meter squared divided by second square. So here diameter is a meter is right. So here 2 is a constant. 9.81 meter per second square. Meter per second square. So which one is a cancel here? Second squares are cancel. Meter squares are cancel. So finally we get meter is right. So this is a unit of loss of head due to friction. So final value 12.675 meter. So now we have HF value. So this HF value is substituted in equation 1. Refer this equation 1 here. This is a equation 1 is right. So two unknowns are there. One is WP, another one is a HF. So now HF values are known. Substitute here. Find out the WP value. WP is nothing but pump work per unit mass of fluid. So here 2 into 9.8 that is 19.6 plus WP is equal to RHS side 9.8 into 10 is right 98 plus HF value 12.675 this value 9.8 G is right. So multiply these two 124.215. Okay. So here from these find out the WP. WP is equal to 202.615 joule per kg. Already I said WP units are pump work per unit mass of fluid joule per kg. Okay. So now WP values are known. So what is the mass flow rate formula? Mass flow rate is equal to volumetric flow rate into density. So volumetric flow rate 1 meter cube per second. I am correct. Meter cube per second. So here density unit kg per meter cube. So here substitute density kg per meter cube. So here meter cubes are cancelled. Finally we get kg per second. So mass flow rate 800 kg per second. So now we have WP and mass flow rate value. So find out the power value. This is our objective. Am I correct? Power is equal to mass flow rate into WP. Mass flow rate is a kg per second. WP is a pump work per unit mass of fluid. Am I correct? So here mass flow rate is a 800. WP is a 202.615. So multiply these two value, find out the power. So here the power is equal to 162.092 kilowatt. So the how it is come kilowatt value here. So refer this equation, mass flow rate into WP. Mass flow rate is a kg per second. So WP is a joule per kg. So kgs are cancelled. So finally we get joule per second. Joule per second is equal to watt. Okay. So multiply these two value, 162.092 kilowatt. Okay. So answer range for this problem 87 to 88 or 161.7 to 163.2. So our answer is within this range, 161.7 to 163.2. Our answer is a 162.092 kilowatt. Okay. So this is our answer. So for further related videos, you can like, share and subscribe my channel. Thank you very much.